take you so much time. I would like to talk to you about SAR technology, leak detection, water losses in Italy, in the world. So, on a circular economy. So, Ramazzotto of 2F Water Venture. It's a company based in Padua. So I'll explain better in the next minutes. I would like to start with a question for you guys. So we can start sharing infos and doing an interactive presentation. So I will try to be as bored than possible. So a question for you. You can answer by chat or just speaking. What do you think is the average percentage of water in Italy? So please just a number, 1%, 2%, 50%, 99%. Do you know what's the average percentage of water loss in Italy? 42%, more or less. Less because this number is increasing from 2019 to this 42% of last year, we suppose. So it's increasing, yeah, 42%. You can imagine to put 100 liters inside a pipe, okay? And after meter, you have just less than 60. So 42% of the water in the pipe network is lost. It's lost due to many things, mostly because of the physical leaks. There are many types of leaks. Main ones are the physical, so the pipe, so water lost in the ground, and that's the main focus of the presentation and the technology. So let's start with the global overview. Let's talk a couple of minutes about sustainable development goals. I hope you all know these 17 goals that are from the United Nations. I think it's 2015. They proposed these 17 goals to better, sustainable, to fight against climate change, to fight against poverty. It's a global act, so every nation should respond to these goals, to these parameters in different approaches, of course, but all of these are important to have a sustainable development all around the world. In particular, number 6, it's ensure availability and sustainable management of water and sanitation for all. Here in Italy, in Europe, sometimes we know that water just came out from the hot houses, but you should know that all around the world there are many issues about water, about contamination, about water scarcity, and this number 6, there are many bullet points. Achievement is to achieve by 2030, for example, achieve universal and equitable access.
Yes, we have like
safe and affordable drinking water for all. You can imagine Africa, you can imagine Asia. Also about sustainably increase water use efficiency across all sectors and ensure sustainable withdrawals and supply of fresh water to address water scarcity and sustainably reduce the number of people suffering from water scarcity. Also here, Africa, Asia, not also. And protect and restore water-related ecosystems, including mountains, forests, wetlands, rivers, and that's here, Italy, in Pianura Padana, in Europe, in America. Let's have to fight pollution. We have to fight climate change. So there are actions we can do all over the world with different approaches. But to save water, to save potable water, then it's constantly decreasing the amount of potable water all around the world. We started decades to refer to water as blue gold. So it's becoming more it's a major goal. So another question for you guys. Here in Italy, so I don't know how many of you are Italian. What do you think? How much does water cost in Italy? I'm talking about raw material. Raw material. So what's the part of the water bill? It arrives you at home that is referred to the raw material, to the water.
I have one question to this. Also the sewage included. So when we use the water and some of the water goes back into the sewage, is price included in the raw materials? Or do you?
In the water bill, we refer to the integrated, in English, how do you say, sistema idrico integrato, integrated hydric system. So it included water from the spring, from the wells to the sewage, to the potabilization, to the sanification. But okay. Just about water. How much does water, raw material, cost? Usually in Italy, the bill is about €2 per cubic meter, from 1.5 to 3, more or less. It depends on the area, it depends on North Italy, South Italy, big companies, small companies. Just give me some data. It's €0. It's €0, yes. Water in Italy is free. We had a couple of referendum also about this. What does it cost? It's the maintenance, is the energy of the pumps, of the wells. It's the operators paycheck. You pay the service, you don't pay the raw material. That's why we have in Italy one of the lowest price of about water. All around Europe, you have much higher costs because of many things. In particular, for example, I don't know, France, they have private industry, so they pay water. The companies want to do profit from it. In Italy, up to the 90s, there was the municipalities that control the networks, and politically logic, they wanted to maintain the costs so low because of elections, you know? But from the 90s, in North Italy, Central Italy, they started to aggregate the municipality to like companies, industrial companies, but with the partners. The partners are the municipalities, and so they can aggregate, put money together to have bigger investments with long-term investments and logic. So they started to push the infrastructure renewment, but in South Italy, there's still many municipality utilities, so there's no industrial use. 2F Water Venture. I'm part of 2F Water Venture and COO. 2F Water Venture is based on Padua. IWS partner, integrated water care systems. It's 3 companies. One is 2F, the other is BM Tecnologie Industriali, also based in Padua. And they have the same owner, Franco Masinello. 2F is the youngest company. It has 5-6 years old. BM is 30 years old. And the third company is Idrostudi, based in Trieste, in Italy. BM and Trieste are specialized in optimization, mathematical models, DMAs in the water system, in aqueducts, and in sewage. 2F is the innovative company that tries to bring in Italy from the water markets. From 2017 is ASTERRA's Italian partner. ASTERRA is the SAR technology based in Israel. We have 4 leak detection teams that find for leaks all around Italy, and we have 3 leak detection teams in external. So what's 2F's contribution? Not just 6, as we saw before. So ensurability and sustainable management of water and sanitation for all, but also 9 in industry, innovation, infrastructure. So build a resilient infrastructure, promote inclusive and sustainable industrialization and foster innovation. But also number 13, climate action, take urgent action to combat climate change impact. So we are fighting with these 3 goals. We are doing our best to reach them. Who's ASTERRA? ASTERRA, based in Israel, delivers a high-resolution spatial layer of subsurface water and salinity content that can be overlaid on any infrastructure to create proactive programs that will have save time, money, and our planet Earth. We will see later what's RECOR for leak detection, MASTERPLAN for pipe deficiency assessment, and EARTHWORKS for infrastructure assessment. Let's a bit about SAR technology. SAR is nothing new. It's 40 years that is used for scanning the world. It has some advantage. Is synthetic aperture radar. It uses many band of the microwave length to penetrate vegetation, soil. So it's not just an optical image. It can see many things, not just it's not just a RGB image with colors. It can see other things. It can interact with a different kind of objects. For example, our L band, it's used to find materials, so it's sensitive to dielectric properties. It's used to determine the material its target on the satellite. The satellite is 640 kilometers from here, more or less. It's our satellite is Japanese, Halos 2. It works with all weather capability, so with clouds, without clouds, day, night, it doesn't matter. It can scan the ground, also with the vegetation. It penetrate 2, 3, 4 meters of the ground. Depends. So What's the first step? First step is to find an area to investigate. For example, our customer are the water utilities, for example, ACEGAS, ERA, ETRA, maybe you know here from Padua and Veneto region. So it can be all the territory managed by the water utility. It can be thousands of kilometers of pipes. Just to let you know, a star image taken from the satellite, it covers 50 per 70 kilometers. So it's pretty huge. We can take it also from the aircraft. We started a couple of years ago with pilot projects. Now we are expanding all around Italy. We are the first in the world using aircrafts to take images, SAR images. So, as I told before, we use microwaves in L-band to penetrate the atmosphere and first meter of the ground. The second step, maybe ASTERRA. ASTERRA is from Astra plus Terra, so to catch the sky with the ground. Okay, prepares raw data for the analysis. So the SAR image has to be clean, has to be prepared for the algorithmic analysis. Okay, what the algorithm does? We find for water in the ground. So what's the process? If there's water and it's potable water in the ground near a pipe, because we have the GIS part of the network, it could be a leak, of course. So the dielectric constant of water, we know it's more or less 80. So we can find water. Then we can highlight the drinking water that has its own conducibility based on salinity. So that is more or less from 100 to 800. You can imagine distilled water, it has so low salinity. Seawater has a high level of salinity. We can distinguish them. First step is to deliver a pre-localization of the leak. So where we found potable water in the ground, soil moisture near a pipe, we put a POI, a point of interest. So we can detect hundreds, thousands of POIs in the water utilities network. It's all digital. We have, of course, also paper ones, but we prefer to use apps, to use dashboards, to have real-time monitoring of the project and its KPIs. So also the client can see minutes per minute, not day per day, but minute per minute, how it's doing, how many leaks are found, where, with photos, comments, statistics, graphs. It's really useful for them. They can start repairing the biggest ones. They can programming, they can download the GIS file. I don't know if you all know what a GIS file is. Geo-reference images, so you can put on softwares like QGIS, I don't know, to overlay, for example, the leaks, the pipes, the aerial overview of the ground. ASTERRA, let's talk about its products. RECOR, MASTERPLAN, EARTHWORKS. RECOR is the most used by 2F. Its goal is to find leaks, so leak detection. You can see the highlighted POIs. POIs is not a point because there are 3 errors. That's the pixel itself is just it's 6 meters. The pixel of the image. There's a georeferencing problem on the overlay from the image to the reality, and also there are other errors. Then there's a error based on R, so it's a circle with a 100-meter radius. So in this 100-meter radius, more or less, we can find the leaks. We go to check for the leaks, but now we'll talk about later about the standard technology. So it's used for detection leaks based on apps. We have the smartphone apps in the ground, in the field. Sorry, our detection teams can upload in real time the leak, video, photo estimation, priority. We can do reports constantly every week. The problem then is to repair them. Usually water utilities are not so prepared to repair hundreds of leaks because it takes time, it takes money, of course. So, but the main thing is pre-localizing leaks it's cost efficient, it's time efficient. Why? Because we don't find 100% of the leaks, and not 100% of the POIs are leaks. There's no one technology that resolves everything. We are a good contribute to cut the time costing, the time. You can imagine at the moment, leak detection is made by teams that check every meter of the pipes, do usually 5 kilometers per day. There are no leak detection teams needed there. There are just maybe 20 teams, private, all around Italy. They do more or less 5 kilometers per day. So you can imagine a water utility with, for example, 3,000 of kilometers of pipes. That is average water utility. How many days or years it takes to check all the pipe system? They have teams in the field all days, every day. And when you finish to check it, you have to again, because leaks, it's constantly appearing. You can put a patch on one and it forms 2 meters after. So leak detection has to be done frequently, constantly. It's proactive approach. It's not responding to emergency. So with such technology, we can cut the timing by 800% because it's less one. Yeah, it could be. Usually cover 500-600 of 100 pipes in just a month, usually. So we cannot find 100% of the leaks, but we can do it, the scan more times per year, more times project. So doing it again and again, we look for the more critical parts, and we just leave all the pipe that it's okay. So that's leak detection. That's a MASTERPLAN is based also with such technology, but it uses different images in time and space. So it takes, for example, 2 SAR images in 6 months from one another, they see the POIs matching together in the same area, in different timing. What's the purpose? The goal is to change pipes. It's not to find leaks. The main problem in Italy is that we have a lot of old pipes. Maintenance is 50 years. That is, it's not useful or being done. Many meters of pipes are really old. They need to be changed with new methods, with new pipes. So the goal is to highlight pipes with 5 criticity levels, okay, from the lowest one, higher one, to put indication to the water utility to invest in pipes change. Of course, change, it's the main, how can you say, the most useful thing to do about water loss. It's really high costly, because you can imagine just to replace 1 kilometer of pipe, something like 150,000 euros. So to change 1,000 of pipes, it's millions and millions, and water utilities don't have this amount of money. Also because our water is so cheap in Italy that they don't have the right investments for the. Third one is earthworks, based on some images to find water in the ground. That could be a problem for dams, for bridges, for rails. So yeah, it can highlight possible problems for the streets, for the pipes, for the houses, and so on. Another for you guys. I don't know if you are all sleeping or it's interesting for you. Talking about water. What do you think? What's the actual detection technology? What we use usually all around the world to find leaks?
Like maybe something to carry around and to go on the street, but which works with the same technology, like also a scanner of the electric constant, maybe?
No, it's much easier. You can imagine we are doing this for 100 years. Human vision, of course, is the first one. The first
pressure
made by the clients. I'm talking about pressure, talking about water coming up from the streets. Yes, of course. But the leak detection teams are using one technology. Do you know which one is? Water flux measurement, yes. But also this one is just a few years that we are using it. We are doing pressure management, we are doing DMAs, so dividing the pipe network into little area, easier to manage. Another one, water level, also but these are indicators of problems of water losses. I can see from the tank that water is going out, but I'm not billing it. So where does it go? I can have pressure alarms. I can see water from the ground, but the actual leak detection technology is noise. We hear the leaks. We hear the leaks with microphones, with acoustic sticks. We will see in the next minute. So after the pre-localization, as I told you, we need to pinpoint the leak in the ground. So we have our internal specialized teams that go all over Italy to find leaks. We use the pre-localization, ASTERRA's pre-localization, but we need to pinpoint the leak. So we have to use the traditional acoustic tools, but we can approach just the 6-7% of the pipe network usually. So we can concentrate our activities in a small area. It's 100 radius per POI, so we do not have to check thousands of kilometers of pipe, but just a few hundreds of them, and the most critical ones probably based on SAR images. And we can put all the effort to find a leak in that area. So I will a couple of tools we are testing here in 2F. It's a couple of interesting ones. The first one is noise logger. I don't know if you know what's a noise logger. Noise logger is a sound recorder. Okay, you can put in the pipe network. It's just magnetic, so you put it. That's a FIDO. We use FIDO because it's really light, easy to use, technological. So it records the sound of in the pipes in the night. So you can put it in the water system. In the day, it's start recording at night. Why in the night? Why in the night? Do you know why in the night? It's the best hour to find leaks. Do you know why? You can tell me, you can write it. We should do leak detection only by night.
Maybe because there is less noise from other sources, like for example, the streets.
That's right, absolutely. There's much less, I don't know if I can say much less, noise, less noise in Texas, yes. So there are many things, many answers. One is, of course, less noise from the cars, from the industries, from environmental noises, let's say this. But also, people at night usually sleep, so they don't use water. So the pressure in the pipes, goes up. There's more pressure in the pipes. More pressure causes more noise from the leaks. So I have less noise from the environment. I have more noise leaks. Why a leak is noisy? Because when a fluid in pressure is through a break in the pipe, it causes a vibration. Vibration is noise, and we detect it here, but also with a microphone. With a microphone, we can be much more accurate, and we can find leaks from 100 meters to 100 meters. So working at night is safer because there are less cars. It's easier. There's high pressure. There's less noise but you can imagine it's impossible to work just at night. So there's technology that can work for us. For example, FIDO, you can put it, you can download the recorded sounds the day after, and the artificial intelligence tells you if a leak is nearby. Of course, you need to pinpoint it again. It's based on 1.7 million audio files database. And it gives you an estimate of the water loss. Okay, that's the dashboard. So the web page, you can see the graphs of the noise. It takes 5 audios in the night, one every hour, from 1 o'clock to 5 o'clock. It records just 7 seconds, and it highlights in red the noisy ones, so you can go in the field to check check the noise and find the leak. There's another point, the mains. What's the mains? Main tracks, the big pipes that comes from the springs, from the wells. They go into the tank. From the tank, there's the distribution pipes that goes to the houses. But the main ones are big pipes from 250 to 2 meters. You can walk inside some of. What's the problem of these pipes? They are important because they transport a lot of water, many water. So a breaking pipe can causes many problems, huge leaks and problems in pressure and in it causes water scarcity and so on. The problem is that we need access points to the pipe. We need to reach the pipe to hear the noise. Main pipes has so few access points because they can go through woods, through fields for many kilometers, 10, 100 kilometers with no access points. So how can you check underground with no access points? Probably you don't even know where it goes. We are testing the Nautilus. It's not the one. There are many approaches, many robots, many of this. You can. I think it's useful. You can put this Nautilus, this robot inside a pipe. It can go up to 35 meters. Single inspection inside the pipe. It records the sound in the pipe, from the pipe. So without access points, you just need to put some transmitters every more or less 150 meters or 1 kilometer. You can find from 0.00 liters per second. It's a really small one. It can detect leaks with the big, medium, little ones, air bubbles, anomalies, for example, changing. I don't know. I will try to. I don't know if you can see this video, because usually videos.
Yes, it's working.
Okay, great. That's it. I think it's nice to say. Fido and Nautilus are just a couple of new technologies that are expanding all over the world. There are a lot of startups from Israeli, mostly because really good in startups based on water. But also America, also Italy, UK. There are a lot of startups. Everyone develops own product to make a contribution to the water leaks, to the leak detection, because there's no single product that can resolve the problem. There's a multi-approach based on pressure management, based on changing pipes, based on DMAs, based on proactive leak detection. There's only with this multi-approach you can effectively reduce the water loss in the pipes. So we have also finished. I want to show you just what's the traditional tools we use in the field to find leaks. So based on noise, there's the classic acoustic stick. Once it was mechanical, just a ion stick. You can put it on the pipe, and you can hear from the stick the vibration, and if there's any leak in the nearby. In the last years, it's upgraded with the electronical amplification. Okay, it's light, cheap, easy to use, useful relocalization of the leak. We use it as a pre-hearing. We call it pre-hearing because we go in the pre-localization. We have to check, for example, 200 meters of pipes. We check every access points. You can try to how you can say find the access points. It's once you start seeing them, you cannot unsee them anymore. It's always in the streets. It's hydrants, it's valves, main valves, services lines, meters, water meters. So these are access points. Also the manuals with the pipes inside. We put the stick. We have our headphones to hear the noise. We have the GEOPHONE. It's a ground microphone. You can, with a bell-shaped noise protection for the streets for environmental noises. You can you touch the ground and hears detects the noise from the underground. So if you can put it on the pipe. You can you know that the pipes is under your feet. You can bell every half meter. You check if there's any noise from the underground. Noise like water bubbles, and you need many years to find the correct leaks. It's used to check or pinpoint per localized leak. Yeah, maybe you can start hearing noise from in a street. You have one access point every 10 meters. You start with a stick. You hear nothing in the first, a little bit of noise in the second, hard noise like a like this noise, and then it's decreasing. So you can imagine the leak is in the highest point. So you can use the GEOPHONE to pinpoint it exactly. Then there's the correlator. Correlator is probably 20, 30 years that we are using it, not so long. It uses two sensors touching the pipe, for example, in this case, the valves, gate valves, and they correlate with the computer the noises from one sensor and the other sensor. And based on diameter, material, and distance between the two access points, they can find the exact starting point of the noise, so the leak point. So you can put, for example, 200 meters diameter, steel material, distance of 100 meters. It can tell you the leak is 25 meters from sensor B. Why diameter? Material in particular is important to correlate. When material, it could be PVC, polyethylene, so plastic ones, it could be metallic, so cast iron, steel, also asbestos, cement, eternit.
Maybe it's because of the sound this material emits when it's leaked.
Yes, it can be useful for us to. We need to know what material is based on because we can detect the right noise, because plastic pipe pipe is a lower frequency, so something like woo, maybe, and metallic is a higher frequency sound, something like there's kind of propagation of vibration. Yes, exactly, because of the hardness of the pipe. The harder is the long distance it covers with vibrations. So plastic pipes has a low range of distribution of the vibration because it's not so hard as material. On the other hand, metallic pipes, cast iron in particular, then steel, then iron, then also asbestos cements, and then the plastic ones. The metallic ones are harder and can propagate the sound for hundreds of meters if there are the possibilities. Pipes can come from 1 meter to at maximum some 50 meters, something like this. It depends on the material distance, but also pressure, of course. Usually, you know, what's the average pressure in water? What's the pressure in your house in bars? 1 bar, 5 bars, 100, 1,000 bars.
I mean, the water has to be transported also in high houses. So it has to be at least a few bars, I guess.
Yeah, sure. It depends,
Or
of course.
maybe 4 or 5 bars.
Yeah, could be. Usually, for example, here in Pianura Padana, I don't know how to translate in Italy. For example, in Padua, in all the cities here with no hills, with no mountains, there's usually 2.5, 3 bars usually. So it covers 30 meters of altitude. Okay. If you have taller houses, you need more pressure to reach higher levels of the building, but you can have different regulation in the houses. But usually you should have something like 3 bars in your water network. In the distribution pipes, if you are in the hills, if you are in mountains, and you have to pump it from the base to the higher levels of many meters, you have to hide the pressure. Pressure causes leaks, and a single leaks with 2 bars, it loses a certain amount of water. The same leak, but with higher pressure, loses much more water. Okay. So this is another important thing. That's why water utilities are doing pressure management to reduce at maximum the pressure in all the water network, to maintain it in 2.5, 3 bars and more. You can find also 10 bars. I can assure you that a little leak in a little pipe of metallic pipe with 7, 10 bars of pressure, it makes a really hard noise. You can detect it from 500 meters, something like this. So that's the correlator, that's acoustic, GEOPHONE, use robots, you can use satellite to pre-localize. There are a lot of tools to find the leaks. Do it, we have to do it. And we have a great opportunity with PNRR, also React EU, this EU contribution in post-COVID situation. So a lot of millions and billions coming from Europe, all around Europe, in particular in Italy, as you know. REACT-EU in particular is for 5 South Italy regions. Sicily, Calabria, Puglia, Basilicata, and Campania. Should be. So specifically, they have the higher water loss percentage. If average is 40-42%, in South Italy you can reach 70%. You can imagine they don't have water in summer, and they are losing 2/3 of the water in the pipe. So they need to change the situation. They need to aggregate the municipalities to have something like an industrial strategy and to invest better the money. And they will have a lot of millions from REACT-EU just for them in 2022 and 2023. So now it's working right, and we are hoping, everyone is hoping that this situation can change in the next years. And there's also Piano Nazionale di Ripresa e Resilienza from this year to 2026. There's of euros all over Italy just for potable water, just for DMAs, pressure management, leak detection, with the aircraft, with noise loaders, with everything. It's in our process, and that's a unique opportunity to fight, to digitalize, to innovate, change pipes all around Italy and Europe. That's final slide. Sustainability, digitalization, resiliency, it's PNRR goals. So 2F water venture is inside all of these ones. Sustainability, of course, our goals is to save water, find leaks. Digitalization, every step, every apps, it's made on smartphone, PCs. Resiliency, to find the leaks, to fight climate change, to respond immediately to the emergencies. 2F water venture is contributing to this. Thank you. That's it.